I would like to welcome our speaker. We're really lucky tonight to have Dale Leckie come in. He's a geologist, speaker, and local best-selling author who worked at the Geological Survey of Canada and as chief geologist at Nexen, which is a large Canadian energy company. He's edited numerous books and published widely on geology of Western Canada. He's an adjunct professor in the Earth, Environment, and Energy at University of Calgary, and he's been recognized for his long-term contributions to geology, and he's an honorary member of the Society for Sedimentary Geology and the Canadian Energy Geoscience Association. He's the 2024 recipient of the Geosciences and Media Award by the American Association of Petroleum Geologists for his first two books. Wildlife, Landscapes, and Geology, and an Alberta, Saskatchewan touring guide, which is what we're learning about tonight, is the third of his books. So if you're interested in his books, I know Dale can put down a link later on where you can get them. And they're all about encouraging people to get out and explore the scenic geology of Alberta. We've had a talk, he had a talk with us on that earlier, I think about 2 years ago, which was really well received. So hope you enjoy tonight. If you have any questions, please put them down in the chat and they'll be more than happy to answer them at the end of the chat tonight. But without further ado, welcome, Dale.
Well, thank you very much, Kaya. That's great. Nice introduction. Thank you to everybody with Nature Calgary for attending. It's great to be back. So what I'd like to do today is talk to you about wildlife, landscapes, and geology, exploring connections. And what is the premise of wildlife, landscapes, and geology? So you take a look at this picture, this painting that we have here, and you see some spectacular landscape in the South Saskatchewan River. Excuse me. And what you see is a lot of different features, and those features are all very attractive to various types of animals. So what do you see there? You can see on the top left, there's sand dunes on the plains. There's glacial lake deposits. We're in an entrenched river valley, so there's badlands. There's meandering river in that entrenched river valley, so we've got features called pools and riffles. There's the point bar, the bar on the side of that river. There's cottonwood forests that are related to that point bar. So what does that all have to do with geology or with wildlife? Well, you can go to certain landscapes like that and see different species. In the sand dunes, you can see kangaroo rats. On the prairies, on the glacial deposits, on the lacustrine sediments, excuse me, sorry, you can see bison, pronghorn antelope, burrowing owls, snowy owls. In the Badlands, you can see prairie rattlesnakes. In that river, you can find lake sturgeon or perhaps trout. Along the shoreline, you can find birds in those cottonwood forests. And we'll talk about that a little bit as the talk progresses. So what is the outline for tonight? Well, we're going to start by looking at rugged mountain cliffs and safe places. We're going to talk about the wildlife of the dry rolling prairies. And we're going to talk about rivers crossing the prairies, deep valleys, cottonwood forests, and prairie oases. So we'll start with rugged mountain cliffs and safe places. This is Big Bend Lookout in Banff National Park, eroding mountain ranges. So most people don't realize, but the Rocky Mountains aren't being formed anymore. They've been eroding for the last 60 million years. Those mountains really quit being formed from a geological perspective about 60 million years ago. So what we see in the Rocky Mountains today is the result of about 60 million years of erosion. And here is a mountain. It's Crowfoot Mountain, right behind Bow Lake. And you can see that eroding mountain. You can see the products of that erosion. There's glacial cirque on the far right, and in front of it is an end moraine. There's talus slopes, there's rock falls, there's debris flows, alluvial fans. The names don't really matter that much, but they're the products of the erosion of those mountains. And that's really important in creating habitat for wildlife, habitat and protection for wildlife. Here we've got a mountain goat in one of those almost steep vertical cliffs. So I said, just to reinforce, the Rocky Mountains are eroding. Well, how do they erode? I showed you that last slide of Crowfoot Mountain. Well, here's a landslide that took place 500 to 1,000 years ago, Jonas Creek in Jasper National Park. And so that landslide, the whole side of the mountain let loose. And the debris ended up in the valley bottom, which is now crossed by the highway. And that debris provides great habitat and protection for animals like hoary marmots and for American pika. Just starting to give you a little bit of flavor for what I'm talking about. So let's start looking at some of those animals and the geology that affects them. Let's look at mountain goats. Mountain goats and lake bottom treats. If you want to see mountain goats, or where should you go? Well, my advice is to check out the local geology. If you've got climbing gear and you can get up to really steep slopes, well, you can go see some of those eroding cliffs where there might be mountain goats to look at. But if you check out the local geology, you might be able to find goats in lower, I'll say, more easier accessible places to go visit. So their habitat during breeding season and most of this early summer is in the remnants of those eroding mountains that we were talking about. They live in some of the most rugged terrain in Canada, and most of us won't get there anymore, be able to climb up those slopes to be able to see them. So where can you go see them? Let's go look at glacial lake beds, which mountain goats go to access minerals as nutrients. So mountain goats, just like us, require mineral nutrients for good body health, and they'll travel great distances to get those nutrients. Once the kids have been born, they'll travel tens to maybe a few hundred kilometers to get those nutrients if necessary, quite often at great risk to themselves, the risk being predators. So where can you go see mountain goats? Well, let's go to Mount Kirkesland Goat Lick in Jasper National Park. So why is it there? You can see in this slide, the left side, we've got the Mayette River flowing into the Athabasca River Valley. And that Mayette River Valley is important for this story. Mount Kirkesland Goat Lick is along Highway 93 along the Athabasca River Valley. Very, very accessible. About 12,000 years ago, the glaciers were melting. The valley glaciers were melting. There was one large valley glacier that came down the Mayette River Valley, and it merged into the Athabasca River Valley and created a big ice dam. So as a result, we had a large lake that formed south and southeast of Jasper, the town of Jasper, in the Athabasca River Valley, Glacial Lake Kirkesland. Excuse me. The ice was melting at that time, and when ice melts, quite often the meltwater is loaded with silt, and that silt was deposited into the lake. This photo here on the bottom right shows you glacial flour, all that eroded debris coming from Hilda Glacier in Hilda Creek. Creeks like that would be flowing into Glacial Lake Kirkesland, bringing silt, clay, minerals, and nutrients. The nutrients, the minerals, they come from limestones and dolomites that make up the mountain ranges all around there. And they were eroded by the valley glaciers. And again, carried as rock flour into the glacial lakes. Minerals like phosphorus, sodium, sulfur, and sort of countless others are what the goats get when they eat that glacial lake silt. If you go to Mount Kirkesland Goat Lick, and here it is here, it's a 9-meter thick bench of these glacial lake silts, and you can see the yellow lines in the back. That's the old bottom of the lake. Extensive. It went way up the valley. And so very, very accessible, easily accessible for the goats. And if you get lucky, you might see them just off the highway there. So that's the story for mountain goats and how they're affected by geology. Let's look at the American pika or pika and mountain debris. So their habitat is, again, those eroding mountains. They're usually found near tree line. They're close to mountain meadows, which they use for grazing. Here's Rock Glacier in Kananaskis National Park. So what you've got there is all this rock debris, and right beside it, mountain meadows, which is just perfect for the perfect habitat for pika. So an interesting thing about pika is they migrated to North America about 500,000 years ago. They came from northern Siberia, southeast Siberia. And another interesting thing is the name pika originates from the Tunguses people that lived in that area. During the last glaciation, northern part of North America was covered by ice. And as a result, sea level, I said last glaciation, every time there is a glaciation, a major glaciation, the water is drawn out of the oceans by these ice masses that would have covered parts of North America. As a result, sea level drops and there was a land bridge that was created between Russia, Eurasia, and Alaska, and that provided the opportunity for the pika to migrate into North America. Everybody knows what pika does. They all summer long, they're scurrying about collecting grasses, sedges, head, and that to store for winter. Here's a great picture of one of them doing that. And what they do is they store that vegetation as a hay crop. Pika don't hibernate during the winter, and so they need nutrients during the winter. So this is what they feed on during most of the winter. Usually they don't store enough, so they'll scurry out underneath a snowbank and eat the vegetation that's in the nearby mountain meadows close to where they're spending the winter. So that's the relationship between geology and American pika. Let's look at the soaring golden eagle and mountain thrush sheets. And again, the close relationship between what golden eagles do and, again, mountain geology. Every spring and summer, golden eagles migrate. In the fall, they migrate south. They migrate south along the Rocky Mountains, and they'll go thousands of kilometers from the Yukon territories to Alaska, down into the United States and into northern Mexico. In the spring, they go the other direction, so thousands of kilometers. They are one of the largest birds we've got in North America. They have a wingspan of a couple meters. So tremendous energy could be expended as they migrate. So they take advantage of the geology to reduce the energy expenditure. Let's go to Jasper. And here's those west dipping mountain ranges. They've been buried deeply, probably 10 kilometers, 7 kilometers here. Then they've been eroded for the last 60 million years to give you the shape that we've got now. Those mountain ranges dip to the west and to the southwest. That's one of the characteristics of our mountain ranges. And they dip into the prevailing westerly winds. That's part of our story here. The next slide, you can see where it's going to come from. And what you can see is the thrush sheets. And all the thrush sheet is a mountain range that dips southwest into the prevailing winds. So this is Jasper. Let's go to let's go to Banff National Park and go up to Mount Norquay and take a look to the south. And you can see the thrush sheets there, Mount Rundle, Sulphur Mountain, and the Sundance Range. Well, Mount Rundle and the ranges to the south all dip to the southwest and west into the prevailing winds, creating really, what am I trying to say? Really good situation to assist the golden eagles migrating. Go to Kananaskis country, and here's Mount Columbola. And just imagine you're there, you're looking straight west or to the southwest, and the winds are coming down at you. That's what the picture I want you to have here. They're coming out of the screen at you. They come down that slope, and then they go up the next mountain range, the next thrush sheet. In this instance, Mount Lorette. And as they do, the winds rise. The winds are following the topography. And so the winds rise, and they create loft or lift for the golden eagles. And as a result, it reduces the energy expenditure that the eagles have to expend again as they migrate. One of the things that I read when I was putting the book together, and I don't believe it because it's a little bit too extreme, but it said that golden eagles taking advantage of these rising winds will expend virtually no energy at all when they're flying. And that's kind of hard to believe, but it does help them make that thousands of kilometers trip every spring and fall. Where do you want to see golden eagles? Well, up and down the eastern edge of the thrush sheets. Jasper, you could go to Roche Miette. We've talked about Kananaskis country. We'll go down into Crow's Nest Pass, and you can see them there on Turtle Mountain or right above the Frank Slide Interpretive Center when they're migrating. Hundreds to thousands of them migrate every season. That's the relationship between geology and golden eagles. Let's leave the mountains and let's go into the dry, rolling prairies and look at some of the relationships between wildlife and landscapes that we've got there. Here's Iron Springs. We've lost the mountains, we've lost the trees, we've lost the vegetation. So completely different habitat. What we've got here is in the Alberta prairies, the Saskatchewan prairies, we're in the rain shadow. We exist in the rain shadow of the Rocky Mountains. So we gain westerly winds coming from the west coast of Canada, British Columbia, Vancouver Island. They're moisture laden. Those moisture laden winds rise up the mountains and it rains. And it rains a lot. And that's why we have the rainforests on the western slopes of Vancouver, Vancouver Island, and the western slopes of British Columbia. The winds keep heading and going eastwards. The clouds or the winds keep losing their moisture. And by the time they get to the eastern slopes, they're pretty dry. So then you've got descending dry air that goes down across the prairies. And that contributes big time to the aridity, the semi-aridity, the dryness that we've got across the prairies. So the geological aspect here is the rain shadow formed in the lee to the east of the Rocky Mountains, affecting vegetation, and then the animals that live in the prairies. So the winds go down that slope into the arid rain shadow of the prairies. If you go into Southwest Alberta Police Outpost Provincial Park, and you can see Chief Mountain off in the distance, you can see how the vegetation changes over a very short distance. You can see the treed eastern slopes heading into the westernmost prairies there. And if you look at a Google Earth image, what you see is the prairies, the dryness, the light green colors across southern Alberta, southern Saskatchewan. That is the grasslands of the prairies. And one of the big controls on that is that we are in that rain shadow on the eastern slopes of the Rocky Mountains. So that aridity, that dryness, it promotes the growth of short and mid-height grasses. And that's what you see here, Southeast Alberta, many berries. This rain shadow has existed, we believe, the geologists believe, for at least 40 million years. And we know that from fossils and nodules that we can find in the sediments that tell us the climate was arid, semi-arid for the last 35 to 20 million years. Isotopes from fossils tell us that the climate was arid as well. We've got fossil soils in northern Montana that are 43 million years old, and those are a type of soil that would only form in a very dry climate. We also had 20, 30 million years ago, giant turtles, almost as high as your waist, that could not withstand freezing. So dry, not overly cold climate for tens of millions of years. And that affects the wildlife that lives in the prairies. A lot of that wildlife has evolved over millions and tens of millions of years to thrive on the semi-arid grasslands, and again, in the rain shadow. Some of the animals that live in the rain shadow, well, one of them is Ord's kangaroo rat, drained lakes and active sand dunes. That's their setting. The habitat of Ord's kangaroo rat is in sparsely vegetated sand dunes across the semi-arid plains. Here's the Great Sandhills Ecological Reserve, great habitat for Ord's kangaroo rat. So why do we have sand dunes in Alberta? A lot of people don't realize that we do. Well, when the ice was melting 10 to 20,000 years ago, and primarily 15,000 years to 10,000 years ago, as the ice pulled back to the north, large glacial lakes formed in front of those that receding ice mass. And much like what you see in this picture here, the ice would pull back and the lakes would drain. And then the prevailing winds, and here's the winds again, part of our story, would be blowing the sands and then sediments that were on that lake bottom and on the shorelines and create sand dunes across much of the prairies. As the ice was melting, we had glacial lakes being formed progressively back to the north and northeast. And so you can see shown in blue there, the extent of those lakes. They weren't all there at the same time. They formed as the ice melted and pulled back, and then the lakes would drain. And then from the blowing wind, this is a map of the sand dunes across Alberta and Saskatchewan, and they're all over both provinces. And that's, again, very important habitat for Ord's kangaroo rats. If you want to go see Ord's kangaroo rats, head into Southeast Alberta, various places, and Southwest Saskatchewan, and go find areas where there are active sand dunes. And the sand dunes are shown in the brown color there, and the blue color is the range of the Ord's kangaroo rat. Most of the sand dunes are vegetated, such as we've got here. And in the last 10 to 12,000 years, we'd get periods of when it would warm up and get drier and the dunes would get active. Well, there are places where they are still active, and several of them across both Alberta and Saskatchewan. Here's Great Sandhills Ecological Reserve. Park in the parking lot, go up the path, and you find this little landmark where all the local cowboys get rid of their boots, but you've got active sand dunes. And that's where you're going to be able to find Ord's kangaroo rat. And here you can see why it's got its name. It's got these large feet. Looks like a kangaroo's feet as well. It's got the long tails. And so the tails assist with locomotion in the sand. They need active sand dunes like that, because if there's too much vegetation, it reduces or makes their locomotion very difficult. You will only see Ord's kangaroo rats at night. You have to go out at night. They're almost like a deer. If you shine a light at them when they're out, they'll just freeze there. And I don't recommend it because you don't want to harass them. But that's when you're going to go find. That's when you're going to go see them, is at night. Even if it's a full moon, there's a strong chance that the rat will, or Ord's kangaroo rat will not come out. Here is a burrow on the left, and on the right, in the middle of that slide, you can see a straight line. And you can see some footprints where you can see where the Ord's kangaroo rat was hopping in the sand and dragging its tail. In the prairies, we've got prairie rattlesnakes, and everybody knows that. Well, prairie rattlesnakes love Ord's kangaroo rats. And there's an interesting little story. This is a bit of a digression here, but Ord's kangaroo rats collect seeds in their fur-lined cheeks like that. The prairie rattlesnakes love to catch and eat Ord's kangaroo rats, but the rattlesnakes cannot digest cellulose. So the seeds that are within the kangaroo rat's pouches, when they get ingested by the snake, they will tend to germinate in the fluids in the snake's body. So 2 to 4 weeks later, the snake passes the carcass of the seeds out of its back end. Some of the seeds will have germinated within the snake in that time, and this is a great seed dispersal mechanism. And I just love that little story, that little anecdote. So that's the story between geology and Ord's kangaroo rats. This is a picture by Dean Francis. He put a lot of art into the book, and it's a picture of the Great Sandhills. Burrowing owls and treeless grassland. Let's take a look at the burrowing owl and how its habitat relates to geology. Well, first of all, it's in the rain shadow of the Rocky Mountains. It lives and inhabits eroding badlands. It's in rolling glaciated terrain where there's minimal tall vegetation. This is prime burrowing owl habitat in Grasslands National Park in a black-tailed prairie dog colony. So burrowing owls nest and raise their young in pre-existing burrows from black-tailed prairie dogs, such as shown on the top left, Richardson's ground squirrels, gophers, badgers even, or coyotes and foxes. And you can see a picture of a burrowing owl at its nest there in a black-tailed prairie dog colony burrow, if you will. An interesting thing, we also have rattlesnakes in this area, and burrowing owls, when a predator goes into the burrow, either to get the eggs or to go after the fledgling birds, it'll make a sound like the rattles of a rattlesnake, hoping to scare away whatever that predator is. So another little anecdote. So burrowing owls require open areas with short and tall grasses, again in the rain shadow of the Rockies. They eat mice, voles, grasshoppers that live in that setting. They'll travel up to 2 kilometers, and then they also want open space, not only to hunt, but to watch for predators that might be coming after them. So that's the relationship between geology and burrowing owls. Let's look at pronghorn antelope and broad open prairies. So for pronghorn antelope, their habitat, they require wide open spaces. That's critical, and you'll see why in a minute. And you get the wide open spaces in the prairies in gently rolling ground moraine, glacial deposits, and old glacial lake beds. And again, the dry prairies in the rain shadow of the Rockies. They don't like treed areas. They don't like gullies and coulees either. One of the things, and you go back to why they require wide open spaces, well, they evolved over time. These very large eyes set far back on the skull. They can see movement up to 5 kilometers away. And that's a very powerful defense mechanism. They developed that defense mechanism because in the past, as recently as 12,000 years ago, the North American prairies were inhabited by American cheetah, American lion, dire wolves, all which were predators of pronghorn antelope, and they could move very fast as well. So the pronghorn antelope could see predators coming up to 5 kilometers away and take off really quickly. They could move with a burst speed of up to about 100 kilometers per hour, which is pretty amazing. So that's the relationship between geology and pronghorn antelope. Let's look at greater shorthorn lizards, also called horny toads if you used to watch old westerns, and eroding badlands. So greater shorthorn lizards. They're about 3 to 4 inches, 8 to 10 centimeters in size. They live in southeast Alberta, southwest Saskatchewan in a few areas. We'll discuss those areas momentarily. Milk River Canyon, Cooley's great area, Many Berries Badlands, Grasslands National Park. They are what's referred to as a sit and wait predator. They eat predominantly ants and grasshoppers, and they blend in. You can see how this shorthorn lizard blends in with the landscape right there. The gray colors are just like the same color as the background where the lichen is not. So they'll sit and wait for ants and grasshoppers to come by, and then they'll scoot out and grab hold of them for their meal. The habitat is eroding badlands, and that's so typical of southern Alberta, southern Saskatchewan. On the south facing, they prefer the south facing slopes of these badlands until it gets really, really hot. They avoid vegetated areas because it hinders their locomotion as well. They do like, as I say, the remnants of eroding badlands. Here's Grasslands National Park, and there's my wife looking for greater shorthorn lizards. And they like these types of slopes, south-facing slopes in the badlands, and a certain type of rock, which we call the bear paw shale. That's great habitat for them. Old marine shales that are about 60 to about 70 million years old. They also like patches of juniper to be in the area because if it gets really, really hot, remember they're cold-blooded, so they have a hard time thermoregulating. So in the bottom of the juniper, they can hide. They can hide from the heat. They can escape the heat. Fine dining. Here's the diet. Here's some scats of a greater shorthorn lizard. You can see grasshopper parts in there. On the left side is a grasshopper leg. They also eat ants, and ants have got uric acid in them, as well as other acids, and greater shorthorn lizards have a hard time digesting or cannot digest uric acid. So they expel the uric acid, which is what that white blob is. It's concentrated uric acid that got scat out from the back end of the greater shorthorn lizard. And so look for scat like this if you want to see the lizards as well. A little bit of a digression. Let's look at the loggerhead shrike. It's a carnivorous songbird. Shrike are the only carnivorous songbirds that we've got. And what that means is they don't have a raptor-like claw to grab hold of and seize their prey, like a hawk does or like an eagle does. They don't have that back talon to grab hold of whatever they're going to eat. So what they do instead is they grab the animals and they will impale them on something sharp that's in the area. Here, it's impaling it on a hawthorn barb. And they do that to store for future consumption, basically like a dry refrigerator, and to impress females of hunting ability. They will use barbed wire fences to their advantage for impaling their prey, such as this greater shorthorn lizard. So that's geology and the relationship between geology and the greater shorthorn lizard, with a digression into loggerhead shrikes. Let's look at entrenched rivers crossing the prairies, meandering rivers, cottonwood forests, and prairie oases. During the last glaciation, 21,000 years ago, most of Canada was covered by two ice masses, the Laurentide ice sheet and the Cordilleran ice sheet, which was in the mountains. The ice was up to 4 kilometers thick, perhaps even further, even thicker further to the north. And so that ice was tremendously heavy. And so it was so heavy that it caused the Earth's crust to sink. Mantle would flow away, laterally away from where the ice was, and it would cause that crust to sink, the Earth's crust to sink. Then when the ice melted, the weight was taken off, and the mantle flowed back into the area. And as a result, the Earth's crust rebounded across the prairies. As the crust rebounded, rivers were cut deep into the prairies. Here we've got on the bottom, North Saskatchewan River, South Saskatchewan River, and you can see how deep those valleys are cut into the prairie landscape because of the crust as it rebounded after the ice melted. For example, here's the Red Deer River Valley. And one of the things that you see here, and the point we want to get across, is the only green that you really see is in the river valleys in the middle of the summer. That just looks like such a dry landscape, except for the circular irrigation patterns. So really, really dry are prairies, semi-arid. And the only green again that we've got is in the cottonwood forests that lie in the river valleys. Another image, you've got the Red Deer River Valley in southeast Alberta, southwest Saskatchewan, and then the South Saskatchewan River Valley. Where's the only green? It's in the river valleys. These cottonwood forests that lie in the river valleys, they cover about 1% of the prairies. That translates into an area of only about 500 square kilometers, but they're so important. Here's Red Deer River Valley, Dinosaur Provincial Park, and you can see the meandering river in the deep river valley. You can see how dry the cliffs, the river valley slopes look. And the only green is along the point bars where the cottonwood forests are. Milk River and its canyon, the same thing. Where's the cottonwood forest? Right along the river valley. Red Deer River Valley, north of Trochu, same thing. Nothing else there except in the bottom, no trees, and really not a lot of green except in the river valley bottom. So those rivers that we're looking at and we're talking about, they typically flood every year, every 5 to 10 years. They typically get high water late May to early June, and the big floods are every 5 to 10 years. Here's high water of the Red Deer River Valley. You can see how dirty it is with the foam. And during the floods of 2013, Calgary, the Bow River would have been like this, but this is South Saskatchewan River at Medicine Hat. And you can see how high the water went. So it's depositing sediment. And that's important for our story. At the same time as the rivers are flooding, cottonwood poplars are going into seed late May to early June. So when we get the rivers flooding, it's about the same time that the cottonwood poplars go to seed. In that image there's probably millions upon millions of cottonwood poplar seeds. And so they float, they're wafted in the wind, and they settle, and where they have to settle to germinate is on areas where sand has been just deposited. The sand and mud has to stay wet for at least a week for the seeds to germinate. So you can see where I've labeled flood level on that image, and that was the high water for the river. Then the water would fall and sand's deposited along a riverbank to provide seed bed. And that's what you see in these two images. The slide on the left, you can see fresh sand that's been deposited along the Red Deer. You can see fresh sand that's been deposited along the South Saskatchewan River after various floods. The cottonwood forests that we're talking about, they're so important for our prairies. They form great prairie habitat. They provide refuge from heat, sun, and wind for so many animals that live in the prairies. You can see these, 15-meter cottonwood forests here. You can see swales in the foreground where it's wet. That's just prime habitat for all sorts of animals, all sorts of wildlife. For example, birds. And this is one summary from one area in the Red Deer River Valley, Dinosaur Provincial Park. 130 bird species are reported from the cottonwood forest, 64 species nesting there. Go to other areas and the numbers are comparable. Here's an American goldfinch. There's a spotted towhee. Reptiles also use the cottonwood forest. Here's a bull snake that climbs trees. It climbs trees to go after birds' nests, birds' eggs, birds' fledglings. I was camping with my wife earlier this year, and there was a big bull snake there in the area in the river valley, and it was trying to go up the trees, and the grackles started going after it. About 20 grackles started harassing this snake as it was climbing up, trying to get at the fledglings, which were in the nests of the grackles. And they eventually scared the snake away. It's quite interesting to see. Cottonwood forest in the understory is great habitat. Here's a porcupine eating the buds and as well as the leaves of hawthorns. So there's the relationship between geology, entrenched rivers, and cottonwood forests, and how it creates great habitat for wildlife. Western painted turtles in these entrenched river valleys, river floodplains, and abandoned channels. A lot of people don't realize we've got turtles in Alberta. They're only natural in a few areas. We'll show you a map right away, but their habitat is slow-moving waters with sandy or muddy bottoms, meandering rivers, oxbow lakes, and marshes. Settings like this. If you want to see painted turtles, and I say for sure, because it's just about 99% guaranteed, go to Lethbridge, go to the Elizabeth Hall wetlands, and you will find hundreds of them. The ones at Elizabeth Hall wetlands were introduced, I don't know when, but there was a time when turtles were pets for people. They got tired of them, didn't want to keep them anymore, and rather than flushing them down the toilet, they would take them out to various places and release them. This is one example. In Alberta, they're native in the Milk River area, southeast Alberta. You can see what I've highlighted there, as well as all across Saskatchewan, you can find them. And the last animal we're going to look at is bison and big boulders. So here's a picture of Mount Edith Cavell. And so the question you should ask is, what does Mount Edith Cavell have to do with bison? So we'll get there. It'll be a long way to get there, but we'll do it. So bison, they migrated to North America from Eurasia, meaning Russia, that part of the world, during glacial sea level low stands, much like we talked about. When sea level was low, the landmass between Russia and Alaska was exposed, was above sea level, and animals could migrate in both directions. So bison covered all of North America, and there's not a lot of geological controls on where they live, but for us in Canada, glacial erratics, big boulders carried by the ice, are important to bison, as well as those glaciations which is all about the geology and the geomorphology, allowed the bison to migrate to North America. So you know what winters are like. I mean, look at it right now. This in Edmonton, in Elk Island National Park, where this picture is taken, today, tomorrow, it's going to be 30 below. So the bison, to survive there, they need thick winter coats. Here you've got a great winter cape that this bison's wearing. And the problem though is during the summer, it gets too hot. So it's got to get rid of those winter coats, that winter cape. And so across the prairies, how did the bison used to do that? They used glacial erratics, carried on the glacier and then let down onto the Earth's surface, the land, as the ice melted. If you go into southeast Alberta, Many Berries area, here's an erratic. And if you look carefully, you can see where the bison were rubbing on it, and they actually smoothed or they polished that boulder, that erratic. If you go to Grasslands National Park, where they've reintroduced the bison and the glacial erratics and you can see the erratics on the prairies, and you can just see the bison rubbing rubbing their winter cape off. So they do that. And they get rid of the fur. But also, as before we go to the next image, look at the beginnings of a depression, a little low-lying area around the boulder. We're going to come back to that in a minute. And so there's a bison where most of its pelt has been rubbed off, again in Grasslands National Park. So that bison hair, it's recycled by birds as well as animals, burrowing animals like Richardson's ground squirrels. Birds will pick up that fur, the bison pelt, from the ground, and they'll line their nests with it for warmth as well as to mask the smell to deter predators from finding the nest. So what about Mount Edith Cavell, where we started this little section? So during the last glaciation, 20,000 years ago, when the ice was at its maximum thickness, there was a big landslide on Mount Edith Cavell. And that landslide went onto a valley glacier that occupied that area, flowed to the north, joined the Athabasca River Glacier, and then flowed to east of Hinton. There it bumped into the Laurentide ice sheet, kilometers thick. And so this ice mass was deflected to the south, the Valley Glacier, and it carried all these boulders that we see up and down the Rocky, just east of the Rocky Mountain foothills and the easternmost Rocky Mountain, I said foothills, yeah, the foothills, all the way down south into Montana. You can see it here. The one in the middle is in Rocky Mountain House. Most of you know about Okotoks and the Okotoks erratic. The next slide is 700 kilometers from Mount Edith Cavell, where that landslide took place. And there's one of those glacial erratics. And some interesting things with this. You can see that low-lying depression. And that depression is important in the spring for certain types of animals because snow is retained there, rainfall and moisture is retained there. It creates ponds that'll last for 1 to 2 to 3 weeks. And that's really important for frogs and toads because in that short period, quite often, the frogs or the toads can life cycle from eggs to tadpoles to maturity. In some instances, in the shortest period of as 10 days. So there's an indirect relationship between geology and sort of, I'll say, frogs and toads, but also on the sides of these boulders, you can see where the rocks have been smooth. Here, on the right-hand side, that was done by the bison. So that relationship between bison and boulders. But then the erratics, these glacial erratics also are important for another reason. In cold spring days when it's sunny, or in autumn days when it's sunny, the boulders will be warmed up by the Earth's rays, and they will radiate heat. They will provide shelter from the wind for snakes and greater shorthorn lizards. So on those cool days, it does provide a warmed microclimate for certain cold-blooded organisms. Here's a prairie rattlesnake, and you can see that it's snug. You can see the grass. It's dry. It's late. It's autumn, and you can see a glacial erratic there. And it's basically the snake is snuggled up to that warm erratic for warmth. So there's the relationship between geology and bison. It's mostly in the erratics, and then whatever else the erratics do to create habitat. So wildlife, landscapes, and geology. My whole premise is knowing a bit of geology helps you discover wildlife and spectacular landscapes. What I talk about in the book, Wildlife, Landscapes, and Geology, is several things. There's lots of maps, just maps all throughout it. And I show wildlife and landscape viewing localities. Here's one example, Highway 41. If you go to the south, just for instance, and then there's a table that tells you what types of animals you might find in that general area in southeast Alberta. A little bit about the geology, just really brief synopsis, what to expect there. I talk about the seasons to see different animals. Different seasons, you can see different animals. For instance, if you want to see the Banff Springs snail at Cave Basin National Historic Site, now is the time to go. And I won't get into it now. Why? It's better to see it. You'll see more of them now than you will during the summer. I don't talk about the conservation status of the animals because that's another topic in itself. But at the beginning of each discussion, I do say what their conservation status is. At risk, safe, whatever. Lots of maps, location maps, where to see the different animals, ranges and occurrences. And I'm a geologist, and what I'm trying to look at is the relationship between geology and the animal, whatever form of wildlife that is. There's landscape art there, as well as wildlife art, because I want the reader to look at the landscape, to look at the animals through the eyes of scientists, but as well as through the eyes of the artists that are viewing them. So with that, I'd like to thank you very much for your time. I'd like to thank the photographers and the artists who let me use their work in the book. And I'd like to I'd like to give thanks to the Canadian Geological Foundation, which has funded printing of this book and my previous two books as well. And that's greatly acknowledged. So thank you very much for your time, and good for questions now.
That was fantastic. Thank you so much, Dale. I learned a lot and I know what I'm doing for the summer. So does anybody have any questions? If you do, you can pop them in the group chat. But to start off, what made you want to write this particular book? Because this is your third one. So what inspired this one?
So my wife and I travel around Alberta, Saskatchewan, the mountains all the time, the prairies. And when we were driving around, I'll say, looking at pictures, looking for pictures, looking at the landscapes and appreciating the landscapes, we started to see that certain animals were being found in certain landscapes. And it was because of that relationship that I started thinking, well, maybe if I'm seeing that, there's something to it. I started doing research into it. And then I just started thinking, well, maybe people would like to learn a little bit more about that. And so that was basically how it started. It was based on, I guess, my whole life driving around the prairies, but it all came together as we pulled the last two books, the preceding two books in, and then that's kind of what drove that. And that's where the idea came from.
Excellent. So we do have a question in the chat. Are any of the animals you discussed increasing in population, or are they all decreasing?
Are they all what?
Are their populations increasing or decreasing?
Okay, so some are, as especially this group, Nature Calgary would know that some animals are at risk. Greater shorthorn lizards, they're at risk. Burrowing owls are at risk. Pronghorn antelope are not at risk. The mountain goats, bighorn sheep are not at risk. So it's a mixed bag. Lots are, but lots are doing very well in the environment. An interesting thing about pronghorn antelope, over the years, especially the last 5 to 10 years, as I drive into northern Alberta, let's say towards Cold Lake or Wainwright, areas like that, I'm starting to see pronghorn antelope further and further north. So it looks like they're extending their range north. I'm seeing them in the Camrose area. I'm seeing them in the Viking area, which 5 and 10 years ago, I would not, well, 10 years ago, never would have seen them there. This group will also know about snow geese. 10 years ago, 15 years ago, snow geese may have, I don't know if they were actually endangered, but they were close to being endangered. Right now, snow geese may be the most populous bird that we've got in North America. It's one of the things I read. That's a bit of an exaggeration. But so some animals are at great risk. Some are doing really fine. Thank you very much.
Excellent. Is there a favorite place that you have to go, and out of all of these areas, is there one that you're just like, if you had to like bucket list them, which one would you send people to?
Every time somebody asks that type of question, they'll get a different answer. It depends on the day. We can see so much in the Rocky Mountains, in the foothills, and into the main ranges. And so,
Yeah,
and you can go into Kananaskis if you're able to go during the week. It's not as crowded. And so, or Jasper East, not Jasper Town Site, but Jasper National Park is not as busy as, let's say, Banff is. So you can go into the mountains, and you can see the animals. Depending on the season and the time, the animals that live in the eroding mountains and the animals that
yeah,
live in the products of those eroding mountains. So I started to talk out. So, I mean, the mountains are great, but other times I just love going into the prairies. And if you can go into those entrenched river valleys, wherever there's cottonwood forests, you're going to see so many birds. And if you go in the spring, I showed a picture of the porcupines.
Yeah,
You'll find deer, fawns, and things like that. And so I'd say spread them out during the season, go east and go west. But if you really want to see wildlife, you have to go into, if you're going into the prairies, you got to go into those river valleys and you got to hang out in the cottonwood forests.
excellent. Good advice. There's quite a few comments just saying that how interesting the talk was and how well done it was and how much people have learned. So I've put information on how to get Dale's book in the chat. Is it available from any local bookshops?
Yeah, the book's available in all of the bookstores in Calgary. Chapters Indigo, Owl's Nest, Shelf Life, Pages on Kensington. Um, Stuff for Men has it. Oh, Stealing Home has it. So it's all through there. You never know
Excellent.
if it's in stock, so you might have to order it. If
Yeah,
people really want a signed copy for Christmas, just you can send me an email. You can see it in the bottom of the slide, and you can do a mailbox pickup. So it's available in the bookstores if you want a signed copy. As I say, we could arrange something through my mailbox, leckyd@shaw.ca.
excellent.
Thank you.
We do have another one, another couple questions here. Are you finding human change such as ski slopes, irrigation, or highway verges? Are they developing certain types of wildlife or wildlife um, avoiding those areas?
Yeah. And I can't be specific on it, but we are seeing, I mean, we do see that because that type of sorry, this is the one, are you finding human change such
Change.
as ski
Yeah.
slopes irrigate? Yeah. And so that does change, I'll say, the microhabitat for a lot of wildlife. And I can't be specific on it, but as we drive around, you do see that. Let me think about it. If you make a ski hill, and it's in a treed area, you're going to open it up and you're going to start seeing certain types of animals going in there during the spring and summer, the grazers. It's much like a forest fire will open up the forest. So to put a ski hill in there, as long as the bikers aren't in there, and I'm not passing any judgment there, that you're going to get different animals going in there to feed on the younger, more tender and different type of vegetation rather than the old growth. And the same thing along roadsides or where irrigation canals might be. It depends how active the irrigation canals might be. There might be vegetation along them, willows and other smaller shrubs, which creates habitat for birds. So it's kind
Mhm.
of a mixed bag there. The thing across the prairies, we used to have shelter belts. They used to be, yeah, they're still growing, but so many of them are being
Yeah.
pulled up. And shelter belts make such great habitat for a lot of birds and a lot of wild mammals as well.
Yeah, that's true. I found more than one bird in the shelter belts for sure. So
Yes.
I know I always slow down as I drive past any one of those. So well, I just want to thank you again for coming out tonight. I know this is your last talk for this season, so thank you so much for making it ours. And I look forward to your to driving some of these routes, looking for wildlife. And I thank you so much for coming out tonight.
Well, thank you very much, Kaya. Thank you very much to Nature Calgary. Okay, take care, everybody. Merry Christmas.
Yes. Good night, everybody.